day everyone, my name is Shane Azuela and today we're going to talk about ozone depletion, acid deposition, and thermal inversion. Earth's atmosphere is made up of 6 layers and the second layer is called stratosphere, which contains the ozone layer. What is ozone layer? They act as a barrier between Earth and ultraviolet radiation from the sun, and also protection from the sun's harmful ultraviolet rays. The ozone layer is made up of highly reactive molecule called ozone, which contains 3 oxygen atoms, and the formula is thanks.
Wow!
Only 18 layer is needed because when there is higher ozone concentrations, temperature and wind brings down the ozone in the troposphere and causes respiratory problems in humans. In this case, ozone becomes a criteria pollutant. Ozone depletion occurring in the stratosphere therefore is a normal photolithic process as well as ozone formation. Well, these following reactions occurs to maintain 18 layer of ozone. Let's go first in equation number 1. 2 oxygen molecules are volatilised, yielding 2 oxygen atoms. Fast-moving oxygen molecule collide with air molecules around them, which is nitrogen and oxygen. These low fast-moving oxygen atoms down, enabling them to bond weakly with the molecule oxygen to form ozone. If they moving fast, they simply bounce off. So, the oxygen atoms has now joined with an oxygen molecule to form ozone. Ozone is very effective of absorbing ultraviolet light, which causes the ozone to split back into an oxygen atom and an oxygen molecule, and they will become thin again. But due to the presence of X, which X stands for free radical catalysts such as chlorine radical, bromine radical, coming from substances made of chloroforms or bromine-based substances such as aerosols, refrigerants, fire retardants, and the like. Nitric oxide radical, hydroxyl radical, which are naturally occurring, they destruct the ozone, especially if there are too many. The ozone formation and destruction is now represented as, let's say X is chlorine, come from CFC or chlorofluorocarbons. CFC is composed of chlorine, fluorine, and carbons. They have long life cycle which favors their accumulation. CFCs do not easily react with other substances. Once the sunlight or UV hit them, they break up, which divides their molecules, causing the release of chlorine. Once the chlorine is released, it is able to react with ozone to form chlorine monoxide and oxygen. When the molecules of chlorine monoxide meets another molecule of oxygen, it breaks up, releasing chlorine, which can destroy another molecule of ozone, creating the catalytic cycle of chlorine. Fortunately, chlorine has natural enemies as well, such as methane. Thanks to them, the natural ozone layer could recover over 50 years as long as CFCs are no longer used on a global level. The ozone depletion is also referred to as the ozone hole, due to the fact that its reduction is not uniform, but mainly concentrated in the Antarctic region with reductions up to 70%. So, our next topic is acid deposition. When sulfur dioxide and nitrogen dioxide react with particulate matters or with water vapor, acid deposition occurs, which causes surface water acidification and affects soil chemistry. Firstly, it's important to understand that rain is slightly acidic because the rain dissolves the carbon dioxide from the atmosphere while falling to the ground to form carbonic acid, a weak acid giving natural rain a pH of 6. So how come this will become lower than 6 or more acidic just because of sulfur dioxide and nitrogen dioxide? It's when we burn fossil fuels like gasoline. Their main sources are from cars, trucks, and power plants. Also come from the burning of coal and oil, which is very smelly. When it is raining, they will dissolve in the rainwater, forming sulfuric acid and nitric acid, making the rain acidic. Remember that each change of 1 in pH is a 10-fold change in acidity. So therefore, changing from 6 to 3 is 10 times and 10 times and 10 times or 1,000 times more acidic. If the rain falls on limestone soils, which are alkaline, the acid will be neutralized. However, if the rain lands on neutral or acid soil or on vegetation, then it can cause damage. Eventually, the rain acid will fall to the lakes and river. As lakes and rivers becomes highly acidic, biodiversity is reduced. Many soil organisms cannot survive in the pH level of soil because certain enzymes which are vital to growth denatured by the acid or are changed in shape so they no longer function. Then, naturally occurring heavy metals that are present in the soil, such as lead, copper, and aluminum, are insoluble, so they are definitely harmless. But with acid rain, they become soluble and contaminates growing plants, which may then bioaccumulate the heavy metals concentration as it is passed from higher trophic level to another. As this impact affects the aquatic and terrestrial ecosystem, it is also imperative to examine the connection between acid deposition and climate change. The major component of photochemical smog, peroxyacetyl nitrate, or PAN, is a combination of different criteria pollutants. PAN is the transport of nitric oxide into rural regions and causes ozone formation in the global troposphere, which can decrease visibility especially in elevated places. The mixed air is normally rises to the atmosphere. In a normal cycle of thermal inversion, an unstable air mass and air constantly flow between warm and cool areas. Due to increased concentrations of pollutants during an inversion episode, temperature increases with increasing altitude, and this disrupts the movement of the mixed air to a higher level since the warm inversion layer then acts as a cup or a layer that forms stable air masses. Thermal inversion is also affected by weather conditions, or it may also occur in some coastal areas because of the upwelling of cold water that lowers surface air temperature. Topography or man-made barriers like high-rise building can also create a temperature inversion. The cold air may be blocked by these barriers and then pushed under the warmer air. Freeing rain or ice storms develop in some areas with a temperature inversion in a cold area because snow melts as it moves through the warm inversion layer. The rain continues to fall and passes through the cold layer of air near the ground. As it moves through this final cold air mass, it becomes supercooled drops, cooled below freezing point without becoming solid. Intense thunderstorms and tornadoes are also associated with inversion because of the intense energy released after an inversion blocks the normal convection patterns of a region. Thermal inversion profiles lead sea surface temperature to decrease on a seasonal timescale via heat exchange at the bottom of the mixed layer, which balances climatological atmospheric cooling in fall and winter. El Niño is a normal climate pattern that describes the unusual warming of surface water in the eastern tropical Pacific Ocean, also known as the warm phase. The opposite of it is La Niña, the cool phase, which is a pattern that describes the unusual cooling of the surface waters of the region. These phenomena are supposed to occur perennial and globally on one end of the equator and on the other. However, abnormalities in the occurrences of these phenomena cause widespread and severe changes in the climate. Rainfall increases drastically in Ecuador and northern Peru, contributing to coastal flooding and erosion due to the convection above warm surface waters. Increased rains brings floods that may destroy properties. On the other side of the world, El Niño brings droughts that threaten the supply of water and destruction of crops affecting agriculture. El Niño and La Niña events also disrupt global atmospheric circulation, bringing colder winters, unusual heavy rain, and flooding in desert areas and other weather abnormalities. Aside from the physical damages caused by disasters, they also come with mental and emotional damage. Victims of disasters may suffer from trauma, depression, or anxiety because of experiencing loss caused by disasters. This is why climate change should not be perceived as an isolated issue. It affects many aspects of human life.